turns out there's something kind of unique about carbon. That's why the only kind of life we know of is carbon-based life form. We know theoretically it's possible to have a life form based on silicon. We don't know of any of it. We wouldn't understand that life form. It'd kind of be like living rocks. But does anybody know what's special about carbon? Why is carbon such a good molecule upon which to build life forms? Well, believe it or not, it's because carbon has the ability to form single bonds, double bonds, and triple bonds, not only with itself, but also with other molecules. Called the amorphous nature of carbon, if you want a fancy word. But this ability that it can make lots of different kinds of bonds enables it to make, you can do millions of different combinations of carbon. And if you're going to build life, you need to have lots and lots of different bonds. As we start talking about kinds of organic compounds, it's going to become a theme that we're going to talk about quite a bit. And that is the idea of polymerization. Polymerization is when small units, known as monomers, join together to form larger units, known as polymers. Everything we look at tonight, we're going to look at monomers, and then we're going to see how they come together to make polymers. We're going to talk about carbohydrates and monosaccharides becoming polysaccharides. We're going to talk about nucleic acids being formed by nucleotides. We're going to talk about fatty acid chains coming together to make lipids, et cetera, et cetera. And the chemical reactions that make it happen are a pair of reactions. One is dehydration synthesis, the other one is hydrolysis. Is just the opposite. You think of it, hydro means what? Water. What does lysis mean? What does it mean to lyse something? Even think of the context. We said that this is putting it together, so what must lysis be? Breaking it apart. So hydrolysis is the breaking of polymers by the addition of water. And we'll see examples of that after the break. Yep. Hydrolysis is the formation of polymers. I'm sorry. Hydrolysis is the breaking of polymers by the addition of water. So we can break those polymers by the addition of water. Those two reactions are the opposite of each other. Dehydration synthesis builds polymers by removing water. Hydrolysis breaks down polymers by adding water. And the last thing we're going to talk about before we go on break here, because it's really not a biomolecule, but we got to get it in there, are hydrocarbons. Hydrocarbons are the simplest organic molecules there are. They're really not important biologically, but we can't leave them out. If we say something is a hydrocarbon, what two atoms do you suppose make them up?
Hydrogen and carbon.
Hydrogen and carbon, simple as And that's just a picture of a hydrocarbon. We're gonna look at pictures of lots of different molecules. Do you have to draw them all? No. They are in your textbook. You can find pictures of them. Will there be a time come test time where I'll show you diagrams and ask you to tell me whether it's a hydrocarbon or a lipid or yes? But I'll show you how to look for parts to help you understand that. It's not as complex as it is. I'll show you the steps to get there. Don't feel overwhelmed. It's one of the reasons we're taking the break now. Because when you come back, you're gonna see a lot of different kinds of chemical diagrams. Don't let that overwhelm you. I'm gonna explain to you, this is how you determine, is it this or is it this? And then you just have to get used to looking at it. All right, be back in 10 minutes. If I have yet to give you credit for your homework, then make a nice reasonable line and I'll give you credit for your homework.
Let me show you how to do it.